In the first module, we are learning about cement properties and different types of properties and applications and testing methods of cement. Okay, and next, admixtures. Admixtures are nothing but these are also one of the extra ingredients which are added in the concrete to improve the performance. Okay, in the normal concrete we may not use these admixtures, but in the special concretes we have to use these admixtures to improve the properties. Okay, so we are going to learn about the admixtures also. And next, aggregates. So here this is the next material which we are going to focus mainly. Okay, and coming to the module 2, here the second module is fresh concrete. That means after learning about the different ingredient materials, now we are going to prepare a concrete. And what are the properties of a fresh concrete? Okay, after mixing those raw materials and adding water, when it is in a fresh state, we will be applying, we will be observing some properties, right? So third properties are very, very important, and we are going to learn about that particular properties and testing methods of that fresh concrete. Okay, and next one, in the third module, we are going to learn about hardened concrete and its testing. Okay, hardened concrete means after adding water, after some time, okay, after some time it will become hard, right? It will become like a solid member. So after getting into hardened state, how it is going to behave, okay, how much strength it can bear. So these all properties can be studied in the third module. Okay, and next one, in the fourth module, mixed design. Okay, mixed design is nothing but we are going to calculate. Yes, just a minute. No? Yeah, so in the fourth module we are going to calculate the mixed proportions, how much quantity of cement you need, or else how much quantity of aggregates you need. Okay, that calculation will be done, and we are going to define the materials quantities required for each and every grade. Okay, that is in the fourth module. And next, in the fifth module, special concretes. Okay, so other than normal concrete, we will be having some special concretes. So we are going to discuss about that special concretes in the fifth module. Okay, yes ma, are you following?
Yes, sir.
Yes,
Yeah,
sir.
my throat is not clear, so due to cold. So if you have any, I mean, if you feel any uncomfortable, just let me know. Okay. Yeah, coming to the main subject here. So now our subject name is concrete technology, right? So we need to know about the concrete. What is concrete? Okay, normally you have already seen that material in the construction, right? So concrete, how you can define? Okay, here concrete is a composite material. So this is the concrete material, right? So how we can define that means concrete is a composite material. So what do you mean by composite material? Just anyone, can you answer? What do you mean by composite material?
Combination of
Yes, just anyone. No?
Mixture of different materials.
Brahmaji, can you repeat?
Mixture of different materials. Sir.
Mixture of different materials. Yes, very good. Next, from others. Yes, just inform your friends to join the class immediately. Other students, only 26 students have joined till now. It is not a good number. Yes. So, can anyone answer that question? Yeah. So, composite material is nothing but, as Brahmaji said, it is a mixture of different materials, right? So here composite material, exactly, composite material means if you manufacture any material by using 2 or more materials. Okay, suppose if you want to manufacture one product, so in that product how many materials you are going to use? Okay, if the materials are more than 2, then that particular material or else that particular product is called as a composite. Okay, so now concrete is a composite material. Why we are calling it as a composite material. Means here we are going to use, okay, for manufacturing of this concrete, we are using cement, water, and aggregates. Okay, we are using 3 different materials to get one product. Okay, to get one material. So this is what that is why we are calling this concrete as a composite material. Okay, so concrete is a composite material which is prepared by using cement, okay, aggregate or water, okay, or else you can call it as a mixture of binding material. Okay, binding material is nothing but the material which is having a binding property, okay, which is having binding property. So not only cement, okay, that is why here I have mentioned binding. Okay, for example, I have kept one material here, cement, but as per the definition, concrete is a mixture of binding material. So binding material is nothing but the material which can bind two materials, that is binding material. So instead of cement you can use any other material also which is having binding property, like you can use clay also, you can use lime. Okay, so instead of cement we can use lime, okay, or else you can use any clay. So that is why we have to define with binding material only. Okay, whenever you are going to define a concrete, we have to use binding material. Okay, so it is a mixture of binding material and aggregates. Okay, aggregates are nothing but, see, these are the aggregates. Here in this picture you can observe this is one of the aggregate, that is fine aggregate. Normally we will call it as sand. Right, and next this is the coarse aggregate. Okay, so in aggregates we will be having 2 types. First one is fine aggregate and second one is coarse aggregate. Okay, this is the coarse aggregate. Okay, and water in a definite proportion. Okay, we cannot take random values, right? Random quantities. Okay, we have to use definite proportions to prepare a concrete. So concrete is nothing but it is a composite material which is prepared by using binding material, one of the binding materials, and aggregates and water in a definite proportion. Okay, so in aggregates again we have fine aggregate and coarse aggregate. Okay, this is what the definition of concrete. I think everyone got the definition now. Yes, right? Any confusion here? Just respond once. Okay, you got it right. 130.
Yes, sir.
Yes, sir.
Yeah, it is a simple definition. Okay, so we have to define like this: concrete is a composite material. Composite is nothing but here we are using more than 2 materials. That is why we are calling it as a composite. So coming to the next one here. Yes, ma. Yeah, tell me, who is that? Yes, ma. Are you asking any doubt here? I am unable to hear your voice clearly. Is my voice audible?
Yes, sir.
Yes, ma. Is it clear now? Can you hear me?
Yes, sir.
Yes, sir.
Yes,
Yeah.
sir.
Thank you. Thank you. Sorry for the disturbance here. I don't have proper internet facilities. Yeah. So coming to the next one here, whatever the concrete we are preparing in the first, okay, that is called as a normal concrete. That means here we are using only basic ingredients. Okay, these are the basic ingredients in the concrete. Okay, this is the cement, aggregate, and water. So again, in aggregates, we have fine and coarse aggregate. Okay, every time I cannot mention that. Okay, so aggregates are nothing but it is a combination of fine and coarse. Okay, so this is the fine aggregate and this is the coarse aggregate. Okay, these both are called as aggregates. Okay, so based upon the size only we are differing. Okay, it is fine and next one is coarse aggregate. Okay, yeah. So in the normal concrete, so we will use only basic ingredients without, I mean, except these three materials. One is cement, aggregates, and water. Okay, or else you can call it as a fine and coarse aggregate. So except these, we are not going to use any other extra material in the normal concrete, not in the special concrete. Okay, in the normal concrete or else in the ordinary concrete, we will use only the basic ingredients. Okay, and coming to the normal concrete, here we will use aggregates, right? So that aggregate, what is the function of aggregate? Means it is going to form one skeleton. It is going to give body to the concrete. Okay, whatever the concrete we are calling. Okay, so this is concrete, right? Okay, so when you pour the particular concrete in one mold, so what is going to happen? It is going to take one shape, right? So that shape, whatever the shape you are getting, whatever the body you are getting, that is because of this particular aggregates only. Okay, so that is why we are calling it as a skeleton matrix. Okay, it is going to give a skeleton. It is going to work as a skeleton of a concrete. Okay, and the aggregate percentage in the normal concrete will be 60 to 75 percentage by volume. Okay, so whenever you are going to prepare a 1 unit of volume, okay, suppose if you want to prepare a 1 unit of volume, 1 unit means here whatever the quantity, it may be 1 kg or it may be 1 ton. Okay, in that 1 unit of concrete, almost 60 to 75 percentage will be aggregates only. Okay, so out of 1 kg, around 60 to 75 means around 600 grams of aggregates will be used in the concrete, and remaining 30 to 25% will be your remaining materials like cement and water. Okay, here aggregates are nothing but both by combining fine aggregate and coarse aggregate. Okay, so by combining these two materials, we are going to use 60 to 75 percentage of aggregates whenever you want to prepare a sample of concrete. Okay, it may be 1 kg, it may be 1 ton also. Okay, whatever the quantity, or it may be 500 grams. So out of 1 unit, okay, that is why here I am mentioning unit. I am not mentioning exact unit here, kg or ton. Okay, whatever the unit you are going to take, in that 1 unit, 60 to 70 percentage will be your aggregates. Okay. Next one, paste. So here, paste quantity 25 to 40 percentage. That means, what do you mean by paste here? After adding these raw materials, okay, normally in the, just a minute. Normally we are going to add cement, aggregates, and water, right? So when you add water into the concrete, so you will be getting one paste here. See, other than aggregates, you can observe one paste like material, right? Cement and water mixture is called as a paste, right? So what is the quantity of the particular paste in 1 unit of concrete? Means here 25 to 40 percentage. Okay, we are going to use around, we are going to use around 25 to 40 percentage of paste in 1 unit of concrete. Okay, so normally here 60 to 75 percentage will be aggregates, and remaining 20 to 25 to 40 percentage will be paste. Paste is nothing but it is a mixture of water and cement. Okay, when you add water into the cement, it will become like a paste, right? So that percentage will be 25 to 40 percentage. And next, voids. Okay, the next percentage will be voids percentage. So voids are nothing but empty spaces. Okay, air spaces. So when you mix water or else when you mix different raw materials for preparing the concrete. So while mixing, there may be a chance of blocking air content also. Okay, small, I mean like small air bubbles will be blocked inside the cement paste or else inside the concrete. Okay, that air percentage will be mentioned in the words. Okay, that is around 1 to 2%. That means out of 1 kg, in that 1 kg, 1% will be air voids. Okay, voids are nothing but empty spaces, okay, without occupying any other materials. Okay, that particular portion will be blocked by air only. Okay, so that is void here, and that void percentage is 1 to 2%. Okay, so here the aggregate percentage is 60 to 75%, and paste volume is 25 to 40%, and voids content is 1 to 2%. Okay, so this part is very, very important. Okay, this aggregate volume. Okay, what is the volume of aggregates in a concrete? In a normal concrete means 60 to 75. Okay, that you have to remember. Okay, you may get the competitive, you may get the question in competitive examinations also. Okay, so the percentage of aggregates in a normal concrete is 60 to 75%. Yeah, and next, coming to the next point here, aggregates shall be inert and strong. That means inert is nothing but, what do you mean by inert here? Inert is nothing but it cannot react with any other materials. It should not react with any other material. That is what inertness, right? So these aggregates are not going to react with any other material like cement or water. Okay, it may absorb, but due to that water or cement, it cannot change its chemical composition. That is what the reaction means, right? So aggregates shall be inert and strong. It should be enough strong to bear the loads. Okay, so here inertness, it should not react with any other materials, and it should be very, very strong. So then only we are going to get good properties while preparing the concrete. Okay, yeah. And next one, coming to, yes ma, is it clear everyone? Just message.
Yes, sir. Yes, sir.
Yes, ma'am. Thank you. Yeah, next one, coming to the ordinary concrete. So I have mentioned the percentages, right? In the previous slide here, I have mentioned different percentages of materials like aggregate. What is the percentage of aggregate in the normal concrete? And what is the percentage of paste? And what is the percentage of air voids? Right? So now we are going to discuss in deeply a little bit more. Yeah, coming to the ordinary concrete. Okay, here, ordinary concrete. So here, these are the ingredients. In the ordinary concrete, we will be having the first ingredient is cement. Okay, the first material is cement. Okay, and the second material is water. And the third one is natural sand or stone dust. Okay, this is very, very important. Just listen carefully. Okay, natural sand or stone dust. So what do you mean by natural sand? Okay, natural sand is nothing but the sand which is collected from the river beds. Okay, or else in the large stones while crushing. Okay, so natural sand is nothing but the sand which is collected at the river beds, right? So next one is stone dust. Okay, we can use, instead of sand, we can use stone dust also. So what do you mean by stone dust here? Stone dust is nothing but, this is the stone dust. Here in this picture you can observe. So what do you mean by that? I think nowadays you are observing this particular stone dust also in the construction. Instead of sand, they are using this particular material. So what is that stone dust? From where you are going to get? Means, see, you will be having huge rocks, right, in the earth surface, on the earth surface. So that huge rock is converted into small aggregates like this. So whenever you are going to convert that huge rocks or its big stones into the small stones, so you will be getting one powder like material, right? So see, if you observe this particular natural this coarse aggregate, this you are going to call it as a conker, right? So now as a technical student, we are going to call it as a coarse aggregate. So how you are getting this particular coarse aggregate, okay, by blasting the huge stones, right? In the engineering geology, you may have heard about blasting also. Okay, so how we are getting this natural, I mean, this coarse aggregate means by blasting or else by doing some processing. Okay, a huge rock ని అంటే మనకు పెద్ద పెద్ద రాక్స్ ని మనం దాన్ని బ్లాస్ట్ చేయడం, మనకు హ్యామరింగ్ చేయడము ఏదో చేసి దాన్ని వీఆర్ గోయింగ్ టు కన్వర్ట్ దట్ పర్టికులర్ హ్యూజ్ రాక్ ఇంటూ స్మాల్ స్టోన్స్. సో వైల్ దిస్ కన్వర్షన్, during this conversion, what is going to happen? The surface may be eroded and you may get small particles. Okay, that small particle is called as a stone dust. Okay, is it clear? Is it clear, ma? Stone dust?
Yes, sir.
Yeah, see, if you have any doubts you can ask me. If you won't, I mean, if you won't get clarity, you can message us. Yeah, so stone dust is nothing but it is one of the finest powder like material, or else it is a particle like material which is obtained during the processing of huge rocks. Okay, okay, and next one, natural stone or crushed. Okay, natural stone, it may be crushed or uncrushed. So natural stone is nothing but we are not doing any processing here. Okay, so we are going to use natural stone also. So this is the natural stone, you can observe here. Okay, this is the gravel which is obtained from the river beds or else seashores. Okay, so here you can see this is naturally obtained, we are not going to do any crushing here. But if you observe this particular aggregates, okay, this is the crushed stone which is obtained from the huge rocks. Okay, larger stones ఉంటాయి మనకు ఎర్త్ సర్ఫేస్ పైన hilly areas లో. So from that hilly areas, from that huge rocks, we are going to crush that stone. Okay, that is why it is called as a crushed stone. Okay, these aggregates are also sometimes called as crushed stone. Okay, so these are the coarse aggregates. Okay, these four pictures will represent the coarse aggregates where we are going to use these particular aggregates in the manufacturing of concrete. Okay, so the first one is cement, second one is water, and third one is natural sand or stone dust. Okay, natural sand ante meeku already telusu kabatti I did not kept any picture here. Stone dust is nothing but this is the stone dust. I think you have observed this particular material in the construction also while constructing your homes or else surrounding areas. Okay, these days they are using they are not using this particular natural sand, they are using, sometimes they are using this particular stone dust only. Okay, and the fourth material is natural stone which may be crushed or uncrushed. Okay, this is the uncrushed stone and this is the crushed stone. Okay, yeah, okay, these are the basic ingredients in the ordinary concrete. Okay, now coming to the next material, that is modern concrete. Okay, in the previous slide we have discussed about ordinary concrete. That means here we are not going to use any other extra material. Whatever the basic materials are there, like cement, water, fine aggregate, and coarse aggregate, these four materials only used for preparing this ordinary concrete. But coming to the modern concrete, here we are going to use extra materials. Okay, along with these four basic materials, we are using some extra materials. So due to that extra materials, what is going to happen means, so why we are going to add this particular extra materials means to improve the property of ordinary concrete. Okay, to improve the property of ordinary concrete. See, every time we cannot adjust with the basic properties, basic specifications. Like if you take some mobile phones or else any other gadgets, so what we will do in the early stages, we will buy only the basic phones, right? Okay, so suppose if you take a 10,000 mobile phone, so in that particular mobile phone you will be having normal features. Okay, some 12 megapixel camera and 4 GB RAM, like that you will be having basic properties. But if you want more specifications, more detailed specifications, more upgraded specifications, what you are going to do, you are going to spend some extra money. So why we are getting that means that manufacturer is going to add some extra features into that mobile phone. He is going to add some extra features into that mobile phone and he is going to increase the cost. So due to that extra features, the quality and the performance of the mobile phone will be increased, right? So like that, here compared to the ordinary concrete, here we are going to add some extra materials that is to improve the properties of that ordinary concrete. It may be in point of strength, it may be in point of resistance to the environment agents, okay, or else it may be in terms of absorption, permeability, whatever the property. Okay, whatever the failures we are going to get, to overcome that failure, we need to do something, right? So that will be overcome by using these extra materials. And these extra materials are called as admixtures. Okay, these extra materials are called as admixtures. Okay, so this is the word we are going to use, admixture. So these, in this particular admixture, we will be having two types. The first one is chemical admixture, and the second one is mineral admixture. Okay, by adding these two admixtures, we are going to improve the material properties, concrete properties. Okay, so now coming to the example. Okay, see, if anyone asks you about the definition of admixture, so how can you define that? What is admixture? Okay, you can define, so if you want to define a cement, you can define a cement. Cement is a binding material which is having cohesion and adhesion property. Okay, and water, you know the water, and you know the aggregate. But how will you define the admixture? What is admixture? Means admixture is a material which is added in the concrete to improve the performance or else to improve the properties of concrete. That's it. Very simple. Okay, it is an extra material which is added in the normal concrete to improve the performance or else to improve the strength. If you want any particular property, okay, if you want to say, if you want to confine the properties or else performance to the definite property, then you can say it as a strength, to improve the strength of the concrete, to improve the hardness of the concrete, to decrease the permeability of the concrete, to decrease the absorption percentage of concrete. Okay, for each and every property we need to use different materials, different admixtures, right? So that is called as admixture. Just a minute, ma. So I think now you got the definition of admixture, right? Yeah. So if you have doubt about this, you can ask me at the end of the session. Okay. Or else at the end of this particular slide. Yeah. Yeah. So now coming to the admixture types, we will be having two types now. One is chemical admixture and second one is mineral admixture, right? So chemical admixture is nothing but here the physical appearance will be in a chemical form. It is like a fluid. Okay, chemical admixture is nothing but we are going to use some liquids in concrete while producing or else while manufacturing the concrete. We are adding some chemical liquid like chemicals in the concrete. So that is why it is called as a chemical admixture. Okay, that's it. It's very, very simple. And examples for this particular chemical admixtures are accelerators, retarders, water reducers. Okay, so here accelerators are nothing but it is an admixture which is going to speed up the reaction process, speed up the setting time of cement. Okay, you will be understanding these terms in the next coming lectures. Okay, now you just remember these words, that's it. Okay, I will be giving clarity because if I tell the definition now, that will not be a clear one now. Okay, I will tell you about these particular terms in the next lectures. Okay, don't worry about that. Okay, chemical admixture, nothing but accelerators are one of the chemical admixtures which are going to speed up the reaction. That's it. Now I want to tell that much only. Okay, to avoid the confusion. And next chemical admixture is retarders. That means these retarders are going to slow down the process. Whatever the process I am talking, that process I will tell you in the next lecture. But here, whatever the reaction is happening in the concrete after adding the water, that will be slowed down. Okay, that is retardants. Okay, and next one, water reducers. That means here we are going to reduce the water content by adding this particular chemical, this particular water reducer. Suppose if you want to produce 1 kg of concrete, okay, and for that 1 kg of concrete I want to use 100 ml of water. Okay, I have to use 100 ml of water, just assume. Okay, for producing 1 kg of wet concrete, I need to use 100 ml of water. But here what I am doing is, by reducing the water quantity to 80 ml, I am using 5 ml of water reducers. Okay, normally the initial quantity of water is 100 ml, right? So now I am reducing the water quantity to 80 ml. But what is the left out water quantity here? 20 ml, right? So now I am not using 20 ml water, but instead of 20 ml water, I am using 5 ml of water reducer only. That means chemical admixture. Okay, this is what happens if you use water reducers. That means here ultimately what I am doing, I am reducing the water content. Okay, so that is why it is called as a water reducer. So this is coming under chemical admixture. Okay, yeah. And next one, mineral admixture. Mineral admixture is nothing but it is a powder like material. Okay, almost it is like a cement. Okay, you know the cement, right? So these mineral admixtures also will be like a cement only. You may have heard about the term fly ash, right? So fly ash, examples of mineral admixture is fly ash, silica fume, GGBS, pozzolanas. Okay, so pozzolanas are nothing but these are the materials which are having cementing properties, which are having silica and calcium in it. Okay, so mineral admixtures are nothing but fly ash, silica fume, GGBS, like which are having the composition of cement almost. Okay, that is why it is called as a mineral admixture. It is a powder-like material, same as cement. Okay, you cannot differentiate those. Okay, fly ash will be like a cement only. Silica fume is also like cement only. And you will be having one more example, that is rice husk. Rice husk ash. That means because rice husk ante telusu kada, aa rice husk vachin tarvata they are going to burn that particular husk, and you will be getting some ash material, right? So that ash is also used as a mineral admixtures. Because why we are using this fly ash or silica fume or GGBS or this rice husk ash means these particular materials will be having the composition same as cement. ఓకే, మనకు సిమెంట్ లో ఏదైతే కాంపోజిషన్ ఉంటుందో అదే కాంపోజిషన్ మనకు ఈ పర్టికులర్ మెటీరియల్స్ కూడా ఉంటుంది. దట్ మీన్స్ ఇట్ ఈస్ హ్యావింగ్ బైండింగ్ ప్రాపర్టీ. These particular materials, fly ash, silica fume will be having binding properties with almost the composition same as cement. That is why we are using these particular mineral admixtures in the preparation of concrete to improve the properties of concrete. So due to these particular properties, due to this particular materials, the strength may be increased, the workability may be increased. Okay, so like this we are going to improve some properties. That is why we are using these materials, and these materials are called as mineral admixture. Okay, so now this is about your admixtures. One is chemical admixture and second one is mineral admixture. So these two admixtures are used in the modern concrete or else any special concrete. To improve the performance of normal concrete, we are using these admixtures. Okay, so is it clear, everyone, about admixtures or else modern concrete?
Yes, sir.
Yes, ma'am. Thank you. So try to respond everyone, so that I can get some confidence about this topic. Yeah. And next point is using above admixtures together, high strength and high performance concrete can be produced, as we have already discussed. Okay, so by using these two admixtures, okay, by using these two admixtures, we can produce high strength concrete or else high performance concrete. High performance concrete is nothing but that particular concrete will be ideal in all aspects. Like strength will be more, workability will be more, permeability will be less, hardness will be more. Okay, and the resistance to environment agents will be more. Okay, or else resistance to acid attack will be more. Like that, that is called as high performance concrete. So by adding these admixtures only we can produce. Without adding this admixture we cannot produce high strength concrete or else high performance concrete. Okay, that you have to remember. Okay, you may get doubt, sir, without adding these admixtures can we get the high strength concrete? By changing the material proportions only. అంటే బేసిక్ మెటీరియల్ ప్రాపర్టీస్ ఓన్లీ చేంజ్ చేసి మనకు లైక్ కెన్ వి ప్రిపేర్ ద హై స్ట్రెంత్ కాంక్రీట్. బట్ నో, వి కెనాట్ ప్రిపేర్. You can change the proportion, but you cannot get more strength. You cannot get high performance because of those change in proportions. Okay, you need to use admixtures, pakka. Okay, Yeah. Thank you. And coming to the advantages of concrete. So what is the advantage? Why we are using concrete in the construction? If you observe, as we have already discussed in the next, previous class, after water, okay, in the globally, water is the most consumable material, right? So after water, we are using concrete majorly. That is the second material which we are going to use more. So why we are using that much amount of concrete in the construction? What is the need? Instead of casting the walls by using concrete, why can't we use other materials? What is the advantage? What are the points to be considered, or else what are the benefits? Okay, for the first advantage, okay, why we are using means lower life cycle cost. Lower life cycle cost, that means relatively cheap material and has a relatively long life with few maintenance requirements, okay, compared to other materials. This particular concrete is very cheap. The cost of this particular material is somewhat less compared to other materials. Suppose if you take metal, if you take a glass, if you take wood, okay, or else if you take a stone, okay, compared to those materials, the cost will be somewhat less. That is why we are using this particular concrete, and has relatively long life. That means the durability, the service life of this concrete, it cannot degrade within short time. Suppose if you take wooden material, so what is going to happen? If you apply, suppose normally if you use that particular wood in a closed space, then that is okay. But if you use in an open space, open area, exposed area, what is going to happen? It is going to subject to some air content or some water content, right? So if you add water on the surface of the wood, what is going to happen? It is going to degrade, right? It is going to absorb the moisture content, and it is going to degrade completely. So we cannot use more time. And if you take glass, so glass, it cannot absorb water. If you apply water, that is okay. But if you apply some force, if you apply any sudden load on the glass material, what is going to happen? It is going to break. And if you take any metal, okay, if you take any metal, if you apply water on the metal, okay, if you apply water on the metal, then what is going to happen? It is going to get corrosion, okay, rust form out manam. So that means that corrosion is also one of the degradation, failure, right? So, and if you apply some sudden loads on the metal, what is going to happen? It can bear, but you may get some dents on the metal member. Like this, every material is having some flaws. Even concrete is also going to have, but compared to this particular materials, it is having more life. See, if you take a concrete and if you take a glass, okay, just apply some force on the concrete material on the wall, and if you apply same force on the glass, which one will break first? Glass, right? So that is what important. That means how many days, how much lifespan, how much time period it is going to give its service without causing any inconvenience to the user, without stopping its functionality. That is what your long life, that is what your durability. Okay, durability is nothing but if you take any particular structure or any particular member, it has to give more service life. It has to give service longer periods without getting any failures. That means without getting failure, how can you identify that failure? Means suppose if any structure is collapsed, then you cannot work with that, right? Sometimes if you get any small crack, you can work without. Suppose if you take a normal walls, okay, you can observe small cracks in the wall also. Okay, that small crack is also like a failure, but it will give some service. I think you can observe in your residential buildings also. Okay, in parapet walls or else walls, normal walls, you will be seeing normal small cracks, right? Okay, so that is also one of the failure, but it is not causing any inconvenience. That means it is not going to stop the functionality, right? That means it is giving service, still it is giving service. So that is what important whenever you are going to prepare a material. Okay, that is why he is mentioning that lower life cycle cost along with these benefits. Okay, and next, mold ability. That means before it hardens, it is very pliable substance that can be easily shaped. That means after adding cement, after adding aggregate, water, after mixing the material, okay, you can observe this particular picture. Just a minute. Yeah, if you observe this particular picture in the first one, see, this is the fresh concrete. After adding these all materials in one place, you will be getting first this material, right? So if you observe this, you can mold this particular paste or else this particular material into any shape, right? Okay, you cannot confine the shape, you cannot confine the molding of this concrete. Okay, you can mold it into any shape depending upon your particular mold. ఓకే, మనకి ఏదైతే మనకు అవుటర్ పోర్షన్ ఉంటుందో ఆ అవుటర్ పోర్షన్ బట్టి నీకు ఏ షేప్ కైనా మౌల్డ్ చేయొచ్చు వెన్ ఇట్ ఈస్ ఇన్ ఫ్రెష్ స్టేట్. ఓకే, దట్ ఈస్ ఆల్సో వన్ ఆఫ్ ది బెనిఫిట్స్. సపోజ్ ఇఫ్ యూ టేక్ వుడెన్ మెటీరియల్, కెన్ యూ మౌల్డ్ ఇట్ ఇంటూ ఎనీ షేప్ like concrete? Just anyone answer? Can you mold wooden material into any desired shape like concrete? Is it possible? Yes, ma'am. Or else can you, if you take any other material as example, like metal, wood, glass, can you mold it into desired shape, required shape, like concrete?
No, sir.
No, right? Because see, if you want to change the shape of the metal, you need to apply some force, you need to apply some temperature. Okay, you need to apply some extra high temperatures. Or else if you take a glass also, then you need to apply some extra temperature, right? Yeah, sorry, ma. Okay, so if you take any glass material or else metal, so there we need to apply high temperatures, and in the high temperature environment only we can work with that to change the shape of the object. But in for concrete, it is not like that. When you add water into the raw materials, then easily you can mold it into any shape without applying any extra temperature, or else without using any other extra materials, any other equipment. Okay, that is the one of the benefit of using concrete. Okay, so moldability before it hardens, that means before getting into hardened state. Okay, when it is in a fresh state, we can mold it into any shape. But once it is getting hardened, once it is getting into hardened state, then again we cannot mold it into desired shape, right? So that is also one of the benefits here. And next one, robustness. Robustness is nothing but here, see, if you take any example of like just a minute. Suppose this is one of the dams now, this is one of the retaining walls. Okay, just for your example I'm telling. So this retaining wall, okay, you may have observed some dams, right? So there we will be having this retaining wall with a concrete member, huge concrete member, okay, constructed over the beside the water. So this concrete member is casted by using huge amount of concrete, right? So whenever you use this particular concrete, so there it will be subjected to some water force. Okay, here we will be having water content, right? So that huge amount of water is going to apply the force like this, right? So this will be resisted by this particular concrete. So with any other material it is not at all possible. If you take metal, you can construct this particular retaining wall with metal also. But what happens if you use that particular metal in the water logging areas? It is going to get some corrosion. Okay, it is going to fail. But what this concrete structure is going to do? It is going to resist the force which is coming from the water, huge force. And the water absorption is also very, very less. It cannot degrade that much amount. It can absorb. Okay, it is going to absorb some amount of water, but it is not going to fail, unlike metal or else wooden structure. You can construct this dam by using wooden structure also, but what is going to happen? They are going to degrade. They cannot resist this much amount of force, right? So that is why robustness is nothing but when you take huge mass concrete, okay, it can resist these huge forces also, which are coming from the mass water. Okay, That is what I want to convey about robustness. And next one, can be designed for desired property. That means you cannot confine the strength of the concrete. You can increase the strength of the concrete by changing the proportions or else by adding different materials. Suppose if you take any wooden material, okay, normally I have gone to the forest and I have sawn one tree into the into one shape. Okay, so if you want to increase the strength of the wooden material, can you increase the strength with natural wood? You cannot increase. You can apply some casing around the wooden material, but you cannot increase the wood strength, core wood strength, right? But here you can increase the strength of the concrete only without applying any casing. Okay, by applying casing or else by applying any other coatings, you can improve the performance. But what I'm talking is you can improve the design properties, you can improve the strength of the concrete itself without applying any coating. So how we can improve that means by changing the material proportions or by adding extra materials like admixtures, as we have already discussed in the previous slide. Okay, by adding that extra materials or else admixtures, we are going to improve the strength or else we are going to design the concrete for desired property. Whatever the strength you need, according to that strength, we can prepare the concrete. We cannot confine the strength of the concrete to the one grade only, one strength only. We can increase the strength up to some points also. Okay, that is also one of the benefits. Okay, you will be getting clarity about these particular terms, all terms, whatever the terms I am discussing now. You are getting this particular clarity with the next lectures. With each and every lecture, you are going to clarify these terms. Sometimes you may not know that what is desired property. How can you confirm it? How can you fix that? Okay, so you can get the clarity of the particular terms in the coming lectures. Okay. Okay, and next one is, yeah, it is strong in compression. That means when you apply the compressive forces on the concrete member, it can bear high amount of loads compared to other materials. So whenever I am telling any positive thing about the concrete, that is with comparison of other materials. Okay, so it is strong in compression. So that means suppose if you take wooden material again, okay, if you take wooden material or else glass, so if you apply compressive forces like this, then compared to that wood, it can bear high amount of loads. That is also one of the benefits. Okay, so these are the advantages of concrete. Okay, why